There is something amiss with Mercury, if we are to believe the latest insider information. The James Webb Space Telescope has uncovered evidence of past life forms on this intriguing planet. Yet, that is not all. Mercury may be entirely different from what we previously assumed, potentially harboring secrets that have been right before our eyes all along. Studying Mercury is deemed exceptionally challenging and perilous for good reason, as we now understand that at the heart of our solar system lies a planet that has rarely been considered for remarkable discoveries. Recent observations from the James Webb Space Telescope have led scientists to suspect that Mercury conceals mysteries it has managed to keep hidden until now. Mercury is a rocky planet, slightly larger than Pluto and significantly smaller than Earth or Mars. Initially, this world was thought to be too scorching to support life or any kind of vegetation. However, researchers have discovered water reserves on Mercury, causing our perception of this planet to shift dramatically, possibly prompting a complete reevaluation of our solar system. Surprisingly, Mercury is not as hot as one might expect. You might think that this small planet would be the hottest in the inner solar system. Theoretically, it should be a furnace. However, this is not the case. Mercury, being the planet closest to the Sun at a distance of merely 58 million kilometers compared to Earth's 150 million kilometers, is not the hottest. Instead, that title belongs to Venus. Although Mercury's atmosphere is hot, it is comparatively mild next to Venus. Due to its proximity to the Sun, Mercury is the fastest planet, hurtling through space at an astonishing speed of 47 kilometers per second, completing a full orbit in just 88 days. This speed can likely be attributed to the Sun's gravitational influence. The surface of Mercury features a diverse landscape, with various craters that narrate tales of a remarkable past and geological activity that may resemble that of Earth. Notable formations include the Caloris Basin, which measures over 1,500 kilometers in diameter, presenting striking visuals on Mercury. Between the craters are vast plains likely formed by ancient volcanic activity, while some areas show signs of contraction, suggesting that the planet has cooled over time. The steep cliffs and towering hills, referred to as lobate scarps, extend several hundred kilometers long and rise up to 3 kilometers high. Other typical features of Mercury include hollows, small bright depressions likely created through sublimation of elements like sulfur and potassium. At its poles, Mercury has pits that remain in perpetual shadow, keeping them sufficiently cold to store water ice. This revelation is akin to a minor miracle, as scientists long believed Mercury was too warm to retain water. If we examine the actual temperatures on Mercury, it quickly becomes clear that we are exploring a realm of extremes. Mercury is not an exceptionally hot, hellish world like Venus. Temperatures can peak at around 427 degrees Celsius during the day but drop to about -173 degrees Celsius at night. Researchers attribute these extremes to the planet's near absence of an atmosphere to retain or distribute heat. In contrast, Venus boasts one of the densest atmospheres in the solar system, formed by a thick shell of carbon dioxide that elevates temperatures to a staggering 467 degrees Celsius. The exploration of Mercury has a rich history. It may seem surprising, but we have had an accurate map of Mercury's surface since 1974. Images captured by the Mariner 10 spacecraft provided unprecedented views, revealing a cratered landscape and geological diversity. Mariner 10 conducted 3 flybys of Mercury, gathering crucial data on its surface composition and atmospheric conditions. However, following these initial missions, there was a significant hiatus in Mercury exploration. NASA faced substantial challenges in sending additional missions to Mercury due to the extreme conditions near the Sun, where the intense gravitational pull and harsh thermal environment posed considerable obstacles. It wasn't until 2004 that NASA launched the Messenger mission Mercury Surface, Space Environment, Geochemistry, and Ranging, aimed at conducting an extensive study of Mercury. This mission was designed to orbit the planet and collect detailed information about its surface, magnetic field, atmosphere, and internal structure. Messenger successfully entered orbit around Mercury in 2011, marking a significant milestone in planetary exploration. The spacecraft provided groundbreaking insights into Mercury's geological history and surface features, discovering evidence of volcanic activity and ancient tectonic processes that shaped the planet. One of MESSENGER's most remarkable findings was the presence of volatile elements such as potassium, sulfur, and sodium on Mercury, which contribute to its exosphere, a thin layer of gases escaping from the planet's surface. The mission provided invaluable data on how these elements interact with solar wind and radiation, shaping Mercury's environment over time. Following MESSENGER's success, interest in Mercury exploration surged, as scientists recognized the significance of studying this planet to better comprehend the formation and evolution of rocky planets like Earth. In 2018, NASA's Parker Solar Probe mission, primarily focused on studying the Sun, offered further opportunities for observing Mercury. The spacecraft's close approach to the Sun enabled scientists to investigate the interactions between solar wind and Mercury's magnetosphere, enhancing our understanding of space weather and its impact on planetary environments. Looking ahead, the James Webb Space Telescope promises to revolutionize our comprehension of Mercury and other planets in our solar system. With advanced imaging capabilities, JWST will enable scientists to analyze Mercury's surface composition in unprecedented detail. By observing Mercury during its transit across the Sun, JWST will assess the planet's atmosphere and surface features, providing fresh insights into its geological processes and potential for hosting water or other volatiles. The discoveries made by JWST could reshape our understanding of Mercury's formation and evolution, shedding light on its dynamic history and habitability potential. By comparing Mercury's characteristics with those of other rocky planets like Venus and Mars, scientists hope to uncover universal principles governing planetary development and the conditions necessary for life. In conclusion, Mercury remains an intriguing and enigmatic world within our solar system. Despite its harsh environment and the challenges associated with exploration, ongoing missions and technological advancements continue to unveil its mysteries. From the ancient observations of early astronomers to the cutting-edge discoveries of modern space missions, Mercury's narrative reflects humanity's enduring curiosity and quest for knowledge about our celestial neighbors. The study of Mercury has been crucial in refining our understanding of planetary formation and evolution, and its proximity to the Sun, along with its unique geological features, offers clues about the early conditions and processes of the solar system. One of Mercury's most striking features is the Caloris Basin, a vast impact crater over 1,500 kilometers in diameter. Formed by a colossal impact billions of years ago, this basin reveals the planet's tumultuous history and the intensity of celestial collisions during the solar system's infancy. Surrounding the Caloris Basin are extensive plains created by volcanic eruptions, indicating that Mercury was once geologically active. The presence of scarps, steep cliffs on Mercury's surface, also narrates a story of contraction and cooling. These lobate scarps are believed to have formed as Mercury's interior cooled and its crust wrinkled and cracked, providing insights into the evolution of Mercury and potentially other rocky planets over time. Mercury's thin atmosphere, or exosphere, is another area of scientific interest. Composed primarily of helium, hydrogen, and trace amounts of other gases, Mercury's exosphere is constantly replenished by the solar wind and the release of volatile elements from its surface. Understanding the dynamics of this exosphere helps scientists explore the planet's interactions with the solar environment and its influence on surface conditions. The extreme temperatures on Mercury present significant challenges for any potential exploration missions. Daytime temperatures can soar to approximately 427 degrees Celsius, 800 degrees Fahrenheit, hot enough to melt some metals, while nighttime temperatures can plunge to around -173 degrees Celsius, -280 degrees Fahrenheit in shadowed regions. These temperature extremes necessitate innovative spacecraft designs and thermal protection systems to endure the harsh conditions near the Sun. Exploring Mercury's polar regions has yielded unexpected findings regarding the planet's potential for water ice. Despite its proximity to the Sun and scorching surface temperatures, Mercury has permanently shadowed craters near its poles where water ice could theoretically exist. The discovery of water ice challenges previous assumptions about the planet's surface conditions and raises fascinating questions about the sources and history of water in the inner solar system. The geological activity observed on Mercury, such as volcanic eruptions and tectonic movements, suggests that the planet was once more geologically active than it is today. Evidence of past volcanic activity indicates that Mercury's interior was once molten and capable of generating eruptions similar to those observed on Earth and Mars. Understanding the timing and duration of these geological processes provides valuable insights into Mercury's thermal history and internal dynamics. In addition to its scientific significance, Mercury holds cultural and historical importance as one of the 5 planets visible to the naked eye from Earth. Ancient civilizations observed Mercury's movements across the sky and incorporated its appearances into their mythologies and calendars. The Greeks and Romans named the planet after their messenger gods, Hermes and Mercury, respectively, reflecting its swift motion across the heavens. Modern observations and space missions have transformed our understanding of Mercury from a distant point of light into a dynamic and complex world. Technological advancements in spacecraft design and instrumentation have allowed scientists to study Mercury's surface in unprecedented detail, revealing a planet with a rich geological history and unique characteristics. Looking ahead, future missions to Mercury, such as the European Space Agency's Bepi-Colombo mission, aim to further explore and comprehend the planet's composition, magnetic field, and geological features. Launched in 2018, Bepi-Colombo is a joint mission between ESA and the Japan Aerospace Exploration Agency, JAXA, designed to study Mercury's surface and interior structure using a suite of advanced instruments. Bepi-Colombo consists of 2 spacecraft, the Mercury Planetary Orbiter, MPO, and the Mercury Magnetospheric Orbiter, MMO. Together, these spacecraft will study Mercury's surface, atmosphere, and magnetosphere, providing complementary data to enhance our understanding of the planet's formation and evolution. In conclusion, Mercury remains a frontier of scientific exploration, offering valuable insights into the processes that shaped our solar system. From its extreme surface conditions to its unique geological features, Mercury challenges scientists to rethink their understanding of rocky planets and their potential for habitability. As our technological capabilities continue to advance, so too will our comprehension of Mercury and its place in the cosmic narrative of planetary evolution.